Okay, we're going to do things a little bit differently today. This next section is 6.5. It's graphing radical functions, as they call them, but basically graphing things like square root functions and cube root functions and see what they look like. So instead of lecturing on it directly, I'm just going to do a couple examples just to show you how this works, because there's no real new theory to talk about here. So we're going to look at graphing, first of all, y equals 1/2 x, and then we'll graph y equals -3 cubed root of x, and then we'll do one more after that as well. So let's start with the y equals 1/2 root x. So the first thing we want to do here is kind of get a sense of what this looks like. Well, we have to recall from the section about inverses that this is a partial inverse of x squared, y equals x squared. So it's a little bit different than a full inverse. And y equals x squared has this basic parabola shape, if you recall. That means that we flip it over the line y equals x, and we get something like this. Okay, if that's something that resonates with you, then it's something to remember. If not, let's just go ahead and do it directly. So here we go. The first thing you always want to do whenever you're graphing something you don't know what to do is you start with a t-table. Now, before we get any further than just writing numbers here and here, we have to think about what is the domain of this function. What numbers can go into y equals 1/2 x, root x, pardon me. And we have to think about the only thing you can take a square root of if we're going to graph it on an xy plane, and we're going to consider only real numbers, not imaginary numbers. The only thing that we can put into a square root are positive numbers. So I'm not even going to start this with my negative values. I'm going to start with 0. 1, 2, 3, 4. Okay? And we're going to go ahead and we're going to put values in. Now, if I put a 0 in, I get 0. Okay, so we put in 0 and we get 0. We put in a 1. We get 1/2 times square root of 1, which is 1/2. You put in square root of 2, and that one I have to actually do on a calculator. I don't know what that is off the top of my head. So some of these are going to require calculators. The only thing I'm going to ask you when you do these problems is to try your very best not to cheat and look at the graph on the calculator right away. Okay, use the calculator to verify your answer. So I'm going to do 1/2 times the square root of 2. We get 0.707. Do 1/2 times the square root of 3 now. .866. And we know the square root of 4 is 2, and 1/2 of that is going to be 1. Okay, so we look at our graph, and it's going to be 0. I'm going to go 1, 2, 3, 4, and we'll do 1, 2. Okay, so we're going to have 0, and then we have, when we get to 1, we get a half, and then we get to 2, we get 0.7, we get 0.8, and we get 1. Okay, and now this is pretty hard to do. Okay, that's my graph. Now, remember that this is basically, a square root function is basically it's half of a parabola laying on its side, okay? So remember that it would kind of go out like this if we had another half of it, okay, but we don't. So that's the idea, it's a half a parabola lying on its side. If we had the parabola that was going to be, pardon me, that's not what I wanted. If I had the parabola y equals root x without the 1/2, it would go up like that. Okay, so this is root x, and this is 1/2 root x, and you can verify this one and this one by looking at the calculator. So anytime you do these problems, graph it first by hand and then check it to see if you got it in the calculator correctly. Okay, so now let's look at how to graph -3 of cubed root of x times cubed root of x. Okay, same idea here. We're going to approach it the same way. We have to remember what the cubed root function looks like basically though. Okay. Remember the cubed root function is the inverse function, that's a cubed, of y equals x cubed. Okay, so just as a quick reminder, x cubed is this kind of thing. We flip that over the line y equals x, here's the line y equals x, and we get something that looks like this. Okay, so it's got this kind of like, it's the same basic picture except that it's on its side. Okay, so that's what we should end up with as our output. So let's go ahead and use this. Let me go ahead and erase this. Don't need this anymore. It should look something like that is my guess. Okay, but we do have a negative, we do have a factor of 3 up front. So anytime you're just trying to figure out what's going to happen here, we want to do, again, a t-table. X, y, sorry, it's a little bit cattywampus. Okay, so let's go from -4 to 4. That'll work fine. 3, -2, -1, 0, 1, 2, 3, 4. Okay, so again, we're going to need our handy-dandy calculator. I'm going to pull out my Wabbit. And again, we want to use the calculator in this instance to help us with the calculation. I don't want to use it to help us with the actual graphing because I want to be able to do it by hand and use the calculator to verify it. So if I put in -4 in for x, I get -3 times, and I'm just going to do -4 to the 1/3 power. $4.76. Okay. And notice that is positive 4.76. Okay. Now I want to show you a quick nice shot calculator shortcut. I want to put in -3, so I'm going to go second, enter, and that's going to pull up the same thing. Now I can edit it. I want to put a -3 in. 4.32. Okay. Again, I'm going to go second, enter. I want to put a -2 in. 3.78, I'll round that to. -1, well this one actually we can do in our head, right? Because -1, the cube root of -1 is -1. So I'm going to get 3. Cube root of 0 is 0. Aha. Now, the only difference between these numbers and these numbers are going to be the sign. Okay, if I were to go back and put in positive one, I would get -3.78 is my answer. I would get -3. I need to fix that. -3 for if I put in a 1, because if I put in -1, I get 3. If I put in a -2, I get 3.78. If I put in a +2, I get -3.78. Put in a -3, I get 4.32. Put in a +3, I get -4.32. And so on. Okay. So I'm going to go, see, we need to go to 4, we need to go to 5 instructions. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. And I'm just going to go ahead and sketch this. I want the point -4, 4.76. -4, there's about 4.76. -3, 4.32. -2, 3.78. -1, 3. 0, 0. And we get the same thing on the other side. Okay. Put in a 1, I get -3. Put in a 2, I get -3.78. Put in a 3, I get -4.32. And I put in a 4, I get -4.76. Okay, so I'm going to remember that I know what the basic shape of this looks like. I'm just trying to connect the dots now. Okay, it's going to go off in either direction. All right. And at this point is a time when, if you so choose, you can put this in your calculator and check to see if your picture is somewhat representative. Okay. So if I go -3 times x to the 1/3 power, and I go graph. Yeah, that looks about right. Okay. All right. Okay, so now we're going to look at how to graph something like this. Okay, 1/2 root x plus 1 minus 2. So it's a square root function at the end of the day, but it's we've added and subtracted some stuff. So here's a little bit of a kind of a way to do this. If I want to graph something like this, where I have a number times some kind of root. It could be a square root. It could be a cubed root. Okay, we're going to be looking at only square roots and cubed roots in this situation. And this, underneath the radical, I have x minus a number, or really x plus a number would work too. And outside that radical, I have adding a number. If I want to graph that, all I really need to do is graph the function without the adding and subtracting, okay, and then move it h units to the right and up k units. Okay. Now remember, if this is a negative, if we have x minus h, we move to the right. If we have x plus h, we move to the left. For k, it goes the way you think it should. Okay. If we want to go, if it's a plus k, I go up, and if it's a minus k, I go down. Okay. So h and k work opposite from one another. Let's look at this particular situation. Okay. So this one, what it says is that if I want to graph 1/2 x plus root x plus 1 minus 2, first I want to graph y equals 1/2 root x. Now we did that earlier, and it looks like this over here. Okay, it's like the square root function, but kind of collapsed, a little pushed down a little bit. And this is basically what it looks like. Okay, remember this was a half, this was 1. Okay, so we plotted using 4 points a few minutes ago. Now, what I want to do then to graph this new function is I'm going to take what I know about this function, I'm going to move it. Every point on this function is going to get moved, and it's going to get moved to the left 1 unit, because we always do the opposite of what it says in here, and down 2 units. Okay, it comes from that. Okay. So if I want to graph it on the same set of axes, and why not, we can do that. We're going to graph the exact same thing, except I'm going to move it down 2 units and to the left 1 unit. So instead of starting here, it's going to start here. And instead of it ending here, I'm going to go down 2 and to the left 1. It's going to go there. So it's really the exact same picture. No, that's not a very good picture. It's really the exact same idea, and this is a little bit collapsed. Okay. But I've moved it. Okay, so this is kind of a tricky way to do it. We graph a simpler function and then we move the function. All right, that's it for today. We'll look at this some more in class.